Hello everyone. In this video we will continue to examine quarks, hadrons, baryons, and mesons as part of topic 7.3, the structure of matter. So in the last video we examined how hadrons come in two general forms. Baryons, which are three quarks, are composed of three quarks. They are fermions, either quark, 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 or three antiquarks. And mesons come in the form of quark, antiquark. So they are composed of two quarks and bosons. And the thing that governs whether they are allowed to exist, whether the laws of physics permit them to exist, is that they are colorless. But there's another important ingredient, something to keep track of, which is that each quark is assigned another quantum number, not just the charge. Each quark is also assigned what is known as a baryon number, which is our second quantum number. This is a quantized number that is associated with a property of the particle, just like charge. Okay, and all quarks have baryon number 1/3. All antiquarks have baryon number -1/3. So if we go back here, right, to our list of quarks, for example, in addition to the electric charge that we labeled here, you could as well put sort of another category known as baryon number. And every single one of these quarks would have a baryon number of +1/3. Every one of these antiquarks would have a baryon number of -1/3. All right, so what are these numbers about? What are they doing? Well, as it turns out, baryon number is generally conserved. This number will allow us to predict in interactions a little bit later on the result of the interaction, because we will need to sort of keep track of the baryon number and recognize that it needs to be conserved. That's where we're going with this property. So if you want to calculate the baryon number of a baryon, notice that you can keep track of that baryon number without sort of adding up the individual quark baryon numbers by simply observing that if you have a baryon, it will have baryon number 1/3 plus 1/3 plus 1/3 equals 1. And notice that if you have an antibaryon composed of a baryon number antiquarks equal to -1/3, -1/3, and -1/3, that will give you a antibaryon number, a baryon number of -1 for that antibaryon. So these guys have a baryon number of +1 total. These guys have a baryon number of -1 total. And then what about mesons? Well, mesons all have baryon number 1/3 and -1/3 total. So mesons have total baryon number 0. How convenient is that? So here's a better way of putting all of this together. Okay. Here's how I keep track of it. Count the baryons. Any baryon has a baryon number of 1. Any antibaryon has a baryon number of -1. And anything else has a baryon number of 0. So that's my recommendation on how to handle that. We'll see more about baryon number when we hit the other quantum numbers and look at conservation laws a little bit later on in the subunit.